Today we are going to do inverse trig functions day 2, and we're going to start off by learning how to use the calculator to find the inverse trig function. And when you're doing this, two things you want to remember is to make sure that your calculator is in radian mode, and I'll just type that for you. Okay, so you want to make sure that the mode is radians, and you're either using sine inverse, cosine inverse, or tangent inverse. So you have to either enter the second key, or the shift key, depending upon what type of calculator you have. Okay, so let's try one. If you want to try or find the inverse of, and it'll look like this: sine inverse of 1/4. So basically, you're trying to find an angle whose sine is 1/4. And so after you change your mode to radians, you're going to actually type in most calculators, you have to type the second key, and then sine, and then enter 1/4. And hit enter. And then you should get your answer. Which should be 0.2527. And then if you want to try another one, you can do tangent inverse of negative 9.65. You follow the same keystroke, but this time do second tangent, and then you should get negative 1.4675. So make sure that you try to type those in to get the right answer. And then if you do, then that means that you are doing it correctly. The next concept is evaluating compositions of functions and their inverses. A composition is when you're basically taking or evaluating two functions and putting it together as one. And you have to make sure you look at or examine the value of x, so you'll know how to evaluate its composition. So what I mean by that is, if you're doing the composition of sine and then the inverse or sine inverse of x, that means that you're trying to find an angle whose sine is that value, and then whatever that value is, you're taking sine of that angle. And whenever you're doing that, the answer will always be that same angle, which is x, if x is in the interval between negative 1 and 1. Because if it's not, then you actually have to evaluate it. And then if you're doing sine inverse of sine of an angle, that means first you're going to find sine of the angle, and then you'll find an angle whose sine is that value. Your answer will always be that angle as long as the angle you're evaluating is in between negative pi over 2 and pi over 2. And both of those are included. Okay? And then an example of that would be if they wanted you to find sine inverse of sine of pi over 4. Well, first we would find out if, since we're finding the sine of this angle, remember, in order to find sine of this angle has to be between negative pi over 2 and pi over 2, because that's where sine has an inverse. And pi over 4, remember, is in quadrant 1, so we're good. So that means that the answer will be the angle. Now, if they ask us to find sine inverse of sine of 5 pi over 4, well, 5 pi over 4 is not in that interval. It's actually larger than pi over 2. Then we can't use that rule. We actually have to find sine of 5 pi over 4 first. Because 5 pi over 4 is actually in quadrant 3. So we will find sine of 5 pi over 4, which is negative square root of 2 over 2. Then we would use find the inverse of sine and figure out which angle in quadrants 1 and 4 would give us that value. And that would be negative pi over 4. So that's how you do it if it doesn't fall in the interval. If it doesn't fall in the interval, you actually have to work it out and you can't use the special property. Okay? The special property for cosine, when you're taking cosine of cosine inverse of an angle, it'll always equal that angle. Same thing as sine, as long as the angle is between negative 1 and 1. And if you're doing the inverse of cosine of an angle, then this one would always be the angle as long as the angle is between 0 and pi. And remember, this is between quadrants 1 and 2. And then this one is between quadrants 1 and 4. Then tangent property, tangent of tangent inverse of an angle will always be the angle for all real numbers. So there's no restriction when you're doing tangent of tangent inverse. However, if you do tangent inverse of tangent of an angle, then this is equal to the angle only if it is between negative pi over 2 and pi over 2, but not including those, because remember that's where tangent is undefined. So it has to be between quadrants, or in quadrant 1 and 4, but not including the quadrant angles. So when you're doing compositions, you have to check the value of x and examine to see if you can use the inverse property. Because if you can't, then you actually have to evaluate it. So let's try a couple. Okay, we'll try a couple of these. Remember, you have to look at the value of x to determine if you can use the special property. Because if you can't, then you have to actually evaluate it. So let's first look at the first one, which is 0.6. So we're doing cosine inverse of 0.6. Well, 0.6 is between negative 1 and 1. So because of that, we can use a special property, and the answer will be 0.6. The requirement was x had to be between negative 1 and 1. And since it is, that's why 0.6 is the answer. When you're doing the inverse, the rule is it has to be between negative pi over 2 and pi over 2, which means it has to be in quadrant 1 or 4. 3 pi over 2 is not. So because of that, we have to actually evaluate. So we're going to evaluate sine of 3 pi over 2. And if you look on your unit circle, sine of 3 pi over 2 is negative 1. Then we have to figure out what angle that is in our domain that will give us an inverse or a sine of negative 1. So remember on your unit circle, you're trying to find out which angle has a sine of negative 1. And the only angle that does would be negative pi over 2. Okay? 1.5. For whenever you're doing cosine, x has to be between negative 1 and 1. And since 1.5 is larger than 1, this is not defined. So sometimes you won't be able to work it out. Okay, for tangent, when you're finding tangent inverse of tangent, remember your angle has to be between negative pi over 2 and pi over 2, but not including. And 3 pi over 4 is not. So we have to actually identify or evaluate tangent of 3 pi over 4, which is negative 1. And then you have to look on your circle and look at between the quadrants of 1 and 4, which one of those will give us a tangent of negative 1. And the only one that will do that is negative pi over 4. Okay? Cosine inverse. Remember the angle has to be between 0 and pi to use our special property. 2 pi is not, so we have to actually identify or evaluate cosine of 2 pi. Cosine of 2 pi would be 1. And then we look between 0 and pi to see which angle gives us a cosine of 1. And the only one that does that is 0. So once you do the inside, then you're going back to those problems that we did in the first day of 5.7. So you're trying to get it to only one function. So you evaluate the middle or the inside one first so that you can do the problems like we did before. Okay, this one, same thing. The angle has to be between 0 and pi, which this one's not, so we can't use our special property. So we have to find cosine of 3 pi. Well, cosine of 3 pi would be like doing cosine of pi, then 2 pi, then 3 pi will land right back where pi is, which would be -1. And then you have to try to find an angle or a who has a cosine of -1. But remember, you can only look between 0 and pi. And this answer would be 0 as well. But what if we did this? I don't have any room, so I'll put it up here at the top. Let me use the same color. Cosine inverse of cosine inverse of 3 pi. Well, if we did something like this, remember, for the inverse, it has to be between 0 and pi. Well, since we're doing the inverse, 3 pi is not even in that interval, so we can't even do this problem. So this would be not defined. So I wanted you to see the difference in example F and example G, where you couldn't even work it out. And then that's it. So you just have to make sure you look at the x value to determine if you can use your special property or if you have to actually work it out and find the value. And that will conclude this lesson.